Hi everyone, thank you for joining us today for this session on AWS Well Architected for Hybrid Networks. My name is Joseph, I'm a solutions architect at Amazon Web Services. I'm joined today, I'm joined by my colleague Ashraf. In today's session, we'll be sharing with you some of the best practices that we've learned over time from the different customers that we engage with. We engage customers at different stages, customers who are just adopting cloud computing, who are trying to build their connectivity between their corporate data centers and AWS. So while this is happening, we realize that traditional enterprise networks can get very complex, right? You start with the initial application, and it's very simple. It's one location, and then before you know it, you've got multiple data centers, in different locations across the world. You have multiple applications trying, to connect to each other, and then in today's development around technology, you find we are bringing on board mobile devices that make these networks even more complex. So it doesn't also help the fact that hybrid networks are still being invested in. Customers, while yes, you have a cloud-first strategy, you're also putting in resources to build your on-prem infrastructure as well. So at AWS, our plan is to help you and provide you with a suite of services that make connectivity to smart cars, smart homes, factories, telcos out there, and all these mobile devices. Our intent is to simplify this for you and make it as seamless as possible, and we make the adoption and bringing on board of these devices very simple. So we'll be going through some of these services today. We'll not go through the entire set of AWS services, but we'll provide you with what we consider to be the fundamental architectural design principles that you should look into. Some of the best practices that we've learned from our customers, from engaging customers in different stages, as well as how to initially select the right service. So as part of this as well, we'll be sharing with you documentation. It will come in the form of barcodes. Feel free to scan that, and you can do your own follow-up sort of review back at your organizations with your colleagues. So what we'll try to do is we'll try and frame this in the well-architected framework and the pillars of the well-architected framework, all the way from reliability, security, performance, efficiency, operational excellence, cost optimization, and sustainability. And we will share with you some of what we call the design principles that you should look to adopt, so that as you're building your infrastructure, you're taking the best guidance possible from AWS. Let's start with the reliability, right? So as you're building your network, and like I said, it's distributed networks, you're likely to have third parties coming on board, and you need to design so that you can take care of this, right? You want a highly available network. If there's a maintenance going on, you can sort of have an alternative while the maintenance is going on, as well as if you've got failures that occur that are beyond your control. You need to have a design that is resilient, and you can quickly fail over and have a plan around that. So for this, we will go through some 4 services. This is not all the subset of AWS services, but for connectivity from your corporate data center to AWS, we provide you with these core 4 core services: Transit Gateway, Direct Connect, AWS Site-to-Site VPN, as well as AWS Client VPN. And we'll try and provide you with guidance around this and how to leverage these core services to build a proper network. So let's get started, right? Traditionally, you'll have your corporate data center, and then you'll have your router where you do your BGP or static routing, and then you have got the AWS cloud side where you have the AWS region, your VPC, your Transit Gateway to provide you with connectivity. So with Direct Connect, AWS provides you with a Direct Connect location, right? And it's in this Direct Connect location where you terminate your Direct Connect circuit, right? And then from that Direct Connect location, you are provided with a Direct Connect gateway to simplify the connectivity, and then you attach that to your transit gateway. Now, this is the basic setup. If you look at this particular design, we've got single points of failure, and there are different points actually. They're in your corporate data center, they're in the Direct Connect location, and you need to think about that. While yes, we've taken care of the high availability aspects of the Direct Connect gateway and the transit gateway, the other components are elements that we need to think about. So let's think about it from a high resiliency point of view. So again, the same architecture, but in this case now, AWS actually helps you, build a highly resilient network by providing you with multiple Direct Connect locations. So good principle is to actually at least have 2 Direct Connect circuits, and then you can extend these Direct Connect circuits to the Direct Connect gateway, and then to the transit gateway. Now, with this particular design, if you think about it, we've actually removed the single point of failure from an AWS point of view, because while we might be running a maintenance on one of the, let's say, AWS routers, you have an alternative path, right? In Direct Connect location 2, where you can, you can send your traffic through, and you're not impacted by an AWS infrastructure management event. Now, we take it back a little bit now to your corporate data center. So how do you need to think about this? So in the same way that we provided you with at least 2 Direct Connect locations, in your corporate data center, you need to think about how do I remove that single point of failure. So think about having at least two routers on your end, and then in this case now you are provisioning 2 Direct Connect circuits from 2 different devices to 2 different AWS locations, and then you simplify this with a Direct Connect gateway as an integration point, and then you can leverage a transit gateway to connect the 2 circuits that you provisioned to multiple VPCs, either in the same region or in different regions, in a very simplified architecture. Now, from an SLA point of view, this kind of architecture actually provides you with 99.9% SLA, and this is factored in also in the transit gateway constructs, as well as the Direct Connect gateway. So now we can actually start having a scenario where we discuss SLA and we have numbers to look at. But this is not it, right? Maybe the business has a requirement for maximum resiliency, and you cannot afford any sort of failure, any sort of downtime, or just a performance hit on your infrastructure. So in this case, how we like to look at it, and how we suggest you look at it, is even in your corporate data center now, you think about having a 1+1 from every device. So instead of having just 2 connections, with 4 connections now, you can actually take into what we actually consider to be maximum resiliency from AWS. In this case, still simplified, very simplified by the Direct Connect gateway, and then you extend this to the transit gateway, and with this you get about 99.99% SLA, because really, if you look at this, it's the points of failure are eliminated from both the Direct Connect locations, as well as from your corporate data center. Now, other customers, over time, after we provided them with Direct Connect, asked us, why can't you actually allow us and enable us to use the AWS backbone to route our traffic between our corporate data centers from different AWS Direct Connect locations? And with this, we actually introduced a feature in Direct Connect, which is SiteLink, which actually enables you and allows you to route traffic while leveraging the AWS backbone. And you don't have to suffer the resiliency issues that come with other third parties. AWS takes care of this. You ride on the AWS backbone infrastructure, and you're able to route between your corporate data centers. So low latency. You can be assured of the multiple connection options that we do provide, and your circuits will always be up. Now, I'd like to mention something that sometimes is perceived wrongly when customers use Direct Connect, and this is as far as link aggregation groups is concerned, right? Now, while Direct Connect does support link aggregation groups, What I'd like to mention is from a resiliency point of view, a lag should be viewed as a single connection, right? Irrespective of the number of connections that you have in your lag. So if you're thinking about that, then you might think about having multiple lags so that you can take care of resiliency. But again, the architecture gets really simplified because you can bundle both 1 gigabit per second circuit as well as 10 gigabit circuits. You know, you can bundle a couple of them, and my colleague Ashraf will take you through that later on. Now, a quick summary of Matters Direct Connect and the architectures that I've shared. For you to be, SLA eligible, you need to think about 2 Direct Connect locations, at least a minimum of 2 connections to 2 different devices in your infrastructure. Or if you can, then you think about 2 different locations, a total of 4 connections, which then provides you with a 99.99% SLA. Now, we know there are scenarios where you cannot have multiple direct connect circuits, right? So for these kind of architectures, we suggest then at the bare minimum, introduce a VPN for backup, because then you're able to, at least if a maintenance is going on in the direct connect location, you can actually, fail over your traffic to the VPN and access your backup over the internet. Of course, say for example, you had a 1 gigabit packet, 1 Gbps circuit or a 10 gig circuit. You need to be aware, of course, as far as the IPsec is concerned, then you don't have the same throughput, right? So that's something you need to really keep in mind so that you don't run into performance issues. And then, based on the architecture that I shared, high resiliency or maximum resiliency, AWS actually provides you with a direct connect resiliency toolkit, which is provided in the direct connect console. And based on the kind of SLA you want to achieve, then this toolkit actually can guide you on what's the best, what's the most optimal architecture that you can adapt for your direct connect circuits. All right. Second option, connecting from on-prem to AWS. AWS also supports site-to-site VPN, and for site-to-site VPN, we give you on the bare minimum 2 ways to connect to AWS. One is using from your customer router or your firewall to AWS. You can connect to a transit gateway, or alternatively, to an AWS region, you can connect to a virtual private gateway, and you can run multiple tunnels to this, right? Now, let's double click a little bit on the site-to-site VPN to virtual private gateway setup. Now, for this, thinking about it from at the bare minimum 2 devices on your end so that you can have multiple tunnels extended to AWS. Then you can create actually multiple IPsec tunnels to the virtual private gateways to AWS to a single VPC in this case. And you'd have to think about this scaled out to whatever number of VPCs you have. Something I need to make you aware of in this particular kind of architecture, you're not, ECMP is not supported, so you cannot really load balance traffic across these tunnels, and that's something you need to think about. But we take care of it in the second option, which is site-to-site VPN to transit gateway, where now in the scenario where you had to create multiple tunnels to multiple virtual private gateways, with this kind of architecture, it's simplified. And you're actually originating your tunnels from the different routers that you have on-prem or firewalls to a single transit gateway. And with this, we do support ECMP, so your traffic is load balanced, and you can actually integrate it to multiple VPCs in a region, and supports more architectures that Ashraf will discuss. Now, site-to-site VPN as well is supported actually over Direct Connect, where you want to, yes, have Direct Connect, but you have a requirement to provide end-to-end, maybe tunneling because of a security requirement in your organization. So with this, same architecture, but now you're actually tunneling your IPsec tunnels over the Direct Connect circuit to a transit gateway. Again, you get ECMP on this particular kind of connection with the added benefits of the Direct Connect circuit is dedicated to you. You don't have the dependencies of the internet, so it's low latency, and you're not impacted by the various aspects of the internet. Then, outside of Direct Connect, outside of site-to-site VPN, what about scenarios where you've got, people working from home, so you've got remote users, and they also want to, access AWS. For this one, you have the client VPN. And with the client VPN, we provision, two elastic network interfaces into your subnets in your target VPC. And then you can have your remote users dial into the client VPN endpoint. And then once you have this in place, you can actually extend this connectivity option using the transit gateway. And it's the recommended way, actually, to different VPCs. So could be specific workload VPCs, so production, dev, test, and so on. So it depends on your requirements. And it gives you a scalable way to have your remote users dial in into your infrastructure securely without compromising on security. Right, so while we've spoken about Direct Connect and site-side VPN and how to leverage that to connect into AWS, it's important that we think about the best practices within the VPC. Now, if you think about how AWS provides the regions, it's good that you take advantage of that, right? So think about doing multiple availability zones for your workloads within a VPC. Use multiple subnets, for example, for your transit gateway, VPC attachments, or direct connect gateway attachments, or for client VPN endpoints, so that you're not creating single points of failure. And then where possible, ensure that you've separated the networking VPC subnets and VPC attachments from your workload subnet, so that the blast radius is completely reduced, and you don't have one point of a possible issue arising. And then lastly, and this is something we forget because we tend to get busy with work and you forget that there are service quarters. Be aware of that, and so that you don't run into that particular challenge where you're exhausting specific quarters. Now, here's a quick summary of some of the quarters that I believe are important and that you need to pay attention to as far as Direct Connect, Transit Gateway, and Site-Side VPN is concerned. So it's limits around attachments and virtual interface limits, route table sizes, the kind of number of routes you can advertise from a specific virtual private gateway, and so on. So just think about that. This is publicly documented, so it's something that you could always look at in your own time. Now, for references on some of the architectures that I've mentioned, and these are publicly available, a couple of barcodes here. Look at this, you'll be able to understand a little bit more on hybrid connectivity, the resiliency recommendations, as well as the quarters I mentioned earlier. Right. Still within the well-architected framework, the second pillar that I'd like to go through is the security pillar and how to take that into consideration as you do your hybrid networks. Now, in AWS, we have multiple AWS security solutions, right, to cover different services. Now, in the context of hybrid networks, we want to look at it from an identity access management point of view to know who is accessing what resources, detective controls to know what actions have been taken or who is trying to do what within your AWS infrastructure, to protect the infrastructure and the data as well from any malicious activity. And what the other thing we want to make sure you're able to do is to actually take action when you detect a certain incident has occurred. So how do we go about this? Let's think about identity and access management for starters. So because we've got networking teams, we've got applications teams, we've got security teams, then it's good to implement the principle of least privilege so that you're keeping networking permissions with networking teams and not application teams, and you're separating duties and only giving people the permissions they need, right? So create a separate account for your networking infrastructure resources, because this becomes shared resources. And to actually help you achieve this, AWS has AWS Control Tower, which helps you create a multi-account structure in a well-designed AWS landing zone, and we provide you with automation tools that actually provide you with the ability to deploy a well-set-up AWS landing zone. And then just a little clearer picture on what I meant by separating the different accounts. So management account for whatever management activities need to be happening, log and archive account because these are seasonal. This requires seasonal access. It's not every day, and then separate workloads in different AWS accounts, so production, dev, and so on, and then have a networking account only for networking activities and networking resources. Right. Let's think about permission management as well, right? We've mentioned about least privilege. Then that would mean restrict access for key APIs, for creating resources and deleting resources to only the networking team and not necessarily to everybody in the networking team, to specific people in the networking team. And then tag your networking resources so that you can identify them when you need to run some maintenance activities. It just helps if you have properly tagged so that this is networking resources for production, these are networking resources for dev, and these are networking resources for test. What about detective controls? You want to know what's going on, in your AWS infrastructure, right? So think about taking advantage of VPC flow logs and DNS logs as well as CloudTrail events, because this gives you visibility on what's going on at different levels or different layers of your networking infrastructure. And AWS actually provides you with Amazon Guard Duty, which then by extension you're able to do threat detection for any malicious activity, or actually do anomaly detection for any unusual behavior. And you can actually take all these findings and pipe them to AWS Security Hub, which then centralizes actually all these findings. And depending on the kind of remediation you want to take, you could either leverage a partner solution from the AWS marketplace. You can send it to a theme, or you can do some custom solution to remediate any threats or anomalies that you might have detected. So this is all provided within Guard Duty and Security Hub. So think about that. And then at an infrastructure protection level and the basic construct that AWS provides you with, we have security groups. I'm sure you're all aware of these ones. At EC2 instance level, these are stateful firewalls that provide you the first line of defense for your EC2 instances. And then we have the network access control list, which is a stateless firewall. So you have to sort of create both inbound and outbound rules to define what traffic you want to be allowed. And then VPC route tables and transit gateways to segment your traffic and sort of define what networks you want to talk to each other and do that kind of segmentation and isolation of traffic. Right. Then, of course, it's not it. We have other AWS services that provide you with the ability to deploy, IPS and IDS appliances. So we have the gateway load balancer that behind which you can deploy your IPS, IDS devices. We have the AWS network firewall, for traffic inspection, both incoming and leaving your AWS infrastructure. And then the Route 53 resolver DNS firewall to protect any malicious activity to your DNS services. So think about, complementing the initial suite of services, Guard Duty, Security Hub that I mentioned, with these other AWS services for infrastructure protection. And then just matters infrastructure. So data protection. Our CTO, Vanna, always says encrypt everything where you can, right? So encrypt your direct connect circuits. Use site-to-site VPN, encrypted tunnels to transfer data from on-prem to the cloud. And at application level, ensure you're doing TLS termination so that you don't have any traffic out there that's not encrypted to your application. And where you can, leverage certificates for authentication at application level where possible. Now, a little bit on Direct Connect encryption. AWS Direct Connect today supports MACsec, so this is for dedicated connections. Again, within Direct Connect, whatever traffic you're sending through, ensure you do TLS, and then do site-to-site VPNs across your Direct Connect. And if that's not enough and you want to do your own appliance, you can actually create a software VPN inside your VPC, a virtual appliance, and you can terminate your IPsec tunnels over this Direct Connect circuit, virtual interfaces. So a little bit just to paint the picture for MACsec support for Direct Connect. If you look, you'll see your customer's router could either sit within the AWS location or could be in your corporate data center. So MACsec is supported to your devices, regardless of where they sit. And just like I mentioned, this is available for 10 gigabits per second circuits and 100 Gbps circuits only at select Direct Connect locations. So that's something you need to look into. And then at a network layer level, from AWS and what we provide you between AWS availability zones within our facilities, we take care of the encryption at optical level, as well as between regions. And if you're using a service like VPC peering or transit gateway peering, because that is supported, then we do take care of the encryption. So that's something you don't really need to think about because we handle within the service. It is a feature within the service. And then finally, on incident response, think about automating so that you are not doing manual tasks. And for this, like I say, guard duty with Security Hub, but then we provide you with Event Bridge as well to sort of build out the automated action and remediation architecture. And a couple of references for you to look at as far as security is concerned. Feel free to take a snapshot of this. And with that, I mark the end of security. I introduce Ashraf to come and take you through the next pillars.
Thank you. Hello, everyone. We're going to talk about the third pillar of the well-architected framework for hybrid networks, which is performance efficiency. And here, customers need to plan the design pattern for their hybrid network when they want to think about performance, because we need to make sure that we meet our business goals. Things to consider when we're planning for performance: we need to choose the right connectivity options when we connect our on-prem to AWS and build our hybrid network. And we talked about multiple options here, like building a site-to-site VPN connection, having a direct connect link. We need to think about the infrastructure location where we want to run our workload, that impact latency, and we need to make sure that we provide the best experience for our customers. And we spoke about AWS regions, and we also have other options that we're going to talk about, like local zones and outposts. And also we need to think about where we run our application. We need to think about application performance and use the right compute design pattern. You can use EC2, you can use containers for your microservices, and when you can, use serverless architecture, because then AWS will take over of the infrastructure and how we scale it to make sure that you focus on the application development and provide the best performance for your customers. Talking about connectivity options, we spoke about VPN. We're going to talk about it a little bit more. Let's think about it from a corporate data center where you have your customer router, and then you selected your AWS region in AWS Cloud. We need to choose the right region closer to your end users to provide the best performance. And in that region, you're going to create your VPCs. The first option, you can terminate your VPN connection over the internet to a private virtual gateway, which is attached to your VPC. So it's a one connection to that VPC where you have your workload. The second option, you have a VPC and you have an EC2 instance running inside it, and you can run a VPN software appliance where you can terminate your VPN connection. The third option is to terminate the VPN connection into a transit gateway, and this gives you more flexibility on how to scale your VPN connections and minimize the configuration for your BGP connections. How? You will have that site-to-site VPN between your customer router to the transit gateway, where it's going to be attached to multiple VPCs. To improve on that and to provide better performance on top of it, you can use an accelerated site-to-site VPN, where you can go through our global accelerator and our backbone to terminate on a transit gateway, which will provide the better performance for your VPN connections. Things to consider when we're thinking about throughput for VPN. If you're using a private virtual gateway to terminate your VPN connection, this is a one-to-one relationship, because you will have one VPN connection to a one VPC where you run your workload. And the throughput per tunnel is 1.25 gigabit per second. And here ECMP is not supported. If you're using to terminate the VPN connection on an EC2 instance where you have a VPN software appliance, again, because the EC2 runs on a single VPC, it's a one-to-one relationship where you will need one VPN connection per VPC. And the throughput depends on the EC2 instance that you choose, and sometimes it's vendor specific. ECMP support with BGP will depend on the software that you use to run your VPN application. If you use Transit Gateway, now you need one VPN connection between your customer router to the Transit Gateway, where you will be connected to many VPCs. So with this, you simplify the management of your BGP connections. And the throughput per tunnel will be 1.25 gigabit per second again. But here the difference is you have ECMP supported with your BGP configuration, where you can load balance between different tunnels to your single VPC or different VPCs, so you can have more throughput. Talking about site-to-site VPN, we terminate these tunnels over the internet. So there's a lot of factors that can impact throughput and latency and jitter when you terminate a VPN connection between your customer router to your VPCs, if you're using, for example, Transit Gateway. How can we improve in this? We use an accelerated site-to-site VPN. With accelerated site-to-site VPN, we shorten the path where you send the traffic over different ISPs, so you will have less impact over the internet, and then you will be directed through one of our VPN edge location through our AWS backbone to terminate the VPN on a Transit Gateway. How it works, from the graph you can see that you will have your customer router in New Jersey, and then you will send the traffic through your local ISP, and it will be routed to the closest edge location for you, and then we will take care of the traffic to send it through our AWS backbone to terminate your VPN connection on the Transit Gateway. So you shorten the path where you're impacted by latency over the internet. So this is regarding VPN. For more business critical workload where latency is very essential and you need to have a more consistent bandwidth and throughput, we talk about Direct Connect. With Direct Connect, it's the same thing like we talk about AWS regions. We need to bring the services closer to the end user to make sure that we provide the best performance. And with Direct Connect, it's a physical link. It's a connectivity between your data center to our data center. So the shortest the path is, the better latency you will have for your applications. And let's say your data center is in the southeast of the US and you want to connect to US East 1. You will have different direct connect edge location where you can terminate your direct connect, and you need to use the right POP where you can terminate your fiber connectivity. If we use Dallas, you will need to go a little bit to the west and go to the US East. So we want to find a shorter path for your connectivity. So we can choose another data center closer to the region where you want to connect. For example, we can have a connectivity where you terminate your direct connect to Ashburn, which is closer to the US East 1 region. So this will shorten the physical connectivity and provide you with lower latency. When you connect using Direct Connect, there's multiple virtual interfaces that you can use to terminate your connectivity. Like VPN, if you use a private virtual interface, you will need one connectivity, one BGP connection between your router and your data center into a private virtual interface in AWS, and that will give you one connectivity to one VPC. If you want to simplify your BGP connectivity, you can use Direct Connect Gateway, which allow you to connect to up 10 VPCs, and then you will minimize how many BGP sessions you need to manage and configure, and scale kind of your connectivity via Direct Connect. To scale it even better and minimize the management, you can use a Transit VIF. Transit VIF, it can be integrated with the Direct Connect Gateway to connect to a Transit Gateway. So you will have your BGP communication and termination between your customer router to a Direct Connect Gateway. Then you can connect the Direct Connect Gateway using a Transit VIF to a Transit Gateway. And this will allow you to connect to multiple VPCs attached to the Transit Gateway. At the moment, we support up to 3 Transit VIFs to connect between your Transit Gateway and Direct Connect Gateway. This is considering connectivity between your customer router to connect to your VPCs in AWS. So it's all private connectivity. If you want to connect to the public resources with AWS, you can have a public VIF. The public VIF, it allows you to have connectivity to the public IP ranges and the public services like S3, CloudWatch, DynamoDB from your local infrastructure, local data center to AWS. Something to also to keep in mind when you terminating in any of these virtual interfaces, you can either use IP version 4 or IP version 6 for your PGP connectivity. Now let's talk about how to scale your bandwidth with Direct Connect. And we're going to talk about two options here. The first one is using link aggregation group. With link aggregation group, and Joseph spoke about it a little bit, where you can actually group multiple Direct Connect links into one logical link. So instead of distributing the traffic into multiple links with different bandwidth, you can put it in a certain lag where you combine the bandwidth together into one single logical link. And remember, when you use a lag, all the links within the lag needs to be active because you want to send the traffic through all of them. So here, the customer router will send traffic through multiple links, and we group them in a lag to send it to a Direct Connect gateway, so you will have more bandwidth. If you're using a 1 gig or a 10 gig links with Direct Connect, you can have up to 4 active links in a lag. And if you're using 100 gig Direct Connect, which is available in certain regions, you can have up to 2 links per lag. The second way on how you can actually scale your bandwidth with BGP and Direct Connect is to use ECMP. And ECMP is a protocol that allows you to load balance traffic between different BGP sessions. And what you can do here is basically you can advertise to the same prefixes at AWS from your local data center using the same BGP attributes, and then ECMP will take over load balancing the traffic between the different links into your VPCs. You can have your Direct Connect gateway with a transit VIF between it and the transit gateway, so you can have you can load balance traffic into your different VPCs and have more traffic going through. Few things to consider with transit gateway and site-to-site VPN when you scale your bandwidth. The maximum bandwidth per VPC that you can have in a VPC is up to 50 gigabit per second, and you can have up to 5 million packets per second. If you're using VPN tunnels, you can have up to 1.25 gigabit per second and up to 140,000 packets per second. We spoke about AWS regions. We spoke about how to build a hybrid network to AWS regions and choosing the right edge locations and so on. Now let's talk about more business requirements. You might have some business requirements where you need to bring the application closer to the end user because latency is critical. And also for certain compliance reasons, you need to process the data on your on-prem. Another option that you can use instead of running your application and workload in one of our regions is running Outpost, using Outpost. AWS Outpost is actually having AWS infrastructure and equipment in your local data center and run it closer to your applications in your local data center, which allow you to lower the latency and also process the data on-prem if that is required. The other option that you can have is AWS local zones. With AWS local zones, you bring the services closer to your end users, which provide you with better latency. Another thing that we need to consider is the performance of your application and the workload that you run on EC2. So when you choose your EC2 instance type, you need to make sure that you choose the newest and the right instance family for your workload to make sure that you deliver the best performance for your application. And if you need more bandwidth, you can enable elastic network adapters. And if you're running your workload as an HPC workload, you can also utilize elastic fabric adapters. Also, another option to bring the EC2 instances closer to each other in a region, in a VPC, is to use placement groups, where you can have your EC2 instances provisions and launched in equipments closer to each other, which will minimize the latency for your application. That wraps up the discussion for the performance slip pillar, and these are some of the references that you can refer to for more best practices and to learn more about it. The next pillar is the operational excellence pillar, and here we're going to talk about some of the AWS services and tools that you can use to monitor actually the performance of your hybrid network and build some monitoring to notify the operation team of any incidents. First, we're going to talk about Direct Connect. We have CloudWatch as a service which provides you with metric to monitor services, and Direct Connect is actually integrated with CloudWatch. And there's a lot of metrics that you can use to monitor your Direct Connect links, the traffic that goes through, the status of the virtual interfaces that can help you mitigate from some incident that can happen. With CloudWatch, you can build notification, like I mentioned, and you can trigger certain actions using Lambda, for example, or just send a notification for the team. Other best practices for Direct Connect, AWS plan maintenance, to fix things and improve our services with Direct Connect. And we send emails to customers about these, and also we push it to the personal health dashboard. With personal health dashboard, PHD, you can actually build notification about these maintenance windows that notify the operation team so you can plan these maintenance. For example, you can fail over to another link or to a VPN connection during the maintenance window so you don't impact your performance and the connectivity. You can monitor packets also by sending the traffic that you send through a Direct Connect to an EC2 instance to build more monitoring and logs to look at, for example, packet drops and why it happens and so on. And with BGP, you can enable bidirectional forward protection, and it will give you a faster way on how you can fail over between different Direct Connect links. Another thing to consider also with Direct Connect is to always test for different scenarios, test for failover. Make sure that you have a backup link. The backup link might be another Direct Connect link, or it can be a site-to-site VPN to make sure that if something happened with one of the Direct Connect links, you have a backup for it. Same thing with VPN. We also integrated with CloudWatch, where you can have multiple metrics to monitor the status of the tunnels, the traffic that goes through. You can create CloudWatch alarms that can notify the teams and so on. You can use the personal health dashboard for the same reason when we plan maintenance. For example, if you configure the 2 tunnels, if we're planning a maintenance in one of them, you want to make sure that the second tunnel is configured and you fail over when the maintenance is scheduled. Other best practices, if your device support BGP, use a dynamic VPN connection, because with that you can use dead peer detection for a faster response, for a faster failover, and PFD as well. So you can have 2 tunnels active at the same time. With VPN to a private virtual interface, we don't have ECMP supported, but still, if you have 2 links available, one of them went down, you can fail over to the second one, which gives you better resiliency. We said we can use Transit Gateway to scale connectivity to multiple VPCs and minimize the PGP configuration that you use. So if you're using Transit Gateway in your hybrid network design pattern, you can use it with the CloudWatch metrics as well on a Transit Gateway level and also on an attachment level to monitor multiple things for your Transit Gateway. Also, not just with CloudWatch to monitor, for example, if packets are dropped for black hole routes or dropped for any other reasons, you can use Transit Gateway Network Manager to actually visualize and monitor your entire global network, not just on AWS and also on-prem, which gives you a better visualization for your hybrid network between different destinations. And you can use Route Analyzer to perform analysis on your routes for your global network. We spoke about your hybrid network, Direct Connect, VPN, and Transit Gateway, how you actually build that, but we also need to monitor the health of your resources where you run your application. So we also, with EC2, we can use CloudWatch metrics to monitor your EC2 instances, and depending on the metrics that you monitor, you can decide on how to scale in and out and protect workload, so you make sure that you don't impact performance and you have the resources that needed to meet your business goals. One last thing I want to mention here is when you want to choose your hybrid network design pattern, it's always important also to define your IP address schema, because you don't want to have overlapping IPs between your on-prem and between your different VPCs. So if you start using the same IP ranges between different VPCs and your on-prem, you're going to have that risk of actually running between 2 different IP addresses at the same time. And we launched a service which is called the IP Manager for VPC, where you can actually track the IP ranges that you use and what is available for on-prem and AWS to make sure that you don't run into overlapping IPs. Another thing to consider also, not just IPs, is to define your ASN, a unique ASN for your Direct Connect gateway and for your Transit Gateway in each region, and also for your on-prem network. Cool. So that wraps up this pillar for operational excellence, and these are some references that you can also refer to. And I'm going to hand over back to Joe.
Thank you, Ashraf. So we've gone through multiple architectures, and we've given you a couple of design principles on what you need to think about. But then, of course, I'm sure you have questions around what does it mean from a cost point of view, right? So I'll provide you a bit of guidance on the things you need to understand from, what actually are the cost drivers, because you need to be aware of this, right, when you're settling on an architecture. So, for good practice, it's good to make sure that you actually understand your top talkers. So is it from on-prem to the cloud, or is it within the cloud? You need to understand how that traffic flow is happening. And this you can do using VPC flow logs. And then additionally, you can think about using the combination of Amazon Athena analysis as well as Amazon QuickSight to build visualization reports to be able to understand where your data transfer costs are coming from, right? Because then that will help you eventually settle on the most optimal architecture that is aligned to your business requirements. And then, of course, with AWS cost and usage reports as well as Cost Explorer, then you can actually manage your AWS costs over time, because then you'll have that understanding of what's going on. Right, so let's double click on the specific architectures so that you can understand where your cost drivers will be coming from, depending on what architecture you settle on. So with site-side VPN, going back to the same initial architecture, you set up your IPsec tunnel between AWS and your corporate data center. Now, one thing you need to be aware of is data transfer into AWS is free. However, you're billed for data transfer out, and as you also bill for the per hour VPN connection charge, depending on how long the VPN is running for, right? So that's something you need to be aware of. Now, this is a simple architecture, right? Now, what about a scenario where I want to leverage the transit gateway to expand my, my setup, simplify it, and make it easy to build connectivity between on-prem and the cloud. So for this, like I said, data transfer in is free. However, beyond the per hour VPN connection charge, as well as the data transfer out back to on-prem, there's a cost that comes with the transit gateway, which is in the VPN attachment, as well as the other attachments to the different VPCs, as well as per GB data processing charge for whatever data is being processed through the transit gateway. So be aware of this when you select this particular architecture. Then, assuming you want to go the accelerated site-to-site VPN and leverage our edge locations, all the costs that I mentioned earlier on still stand. And there's an additional data transfer charge, which is in the dominant direction of your traffic. So depending on what direction the data is being accelerated towards, then that cost comes. The other costs, like I said, do remain on the transit gateway as well as on the VPN. All right, what about Direct Connect and virtual private gateway as your architecture? So for this, the cost drivers, in the inbound direction data transfer in, there's no cost. There's no cost for Direct Connect gateway, the construct itself. However, there is a Direct Connect port hour rate charge that comes with this architecture, as well as data transfer out cost. So this sort of becomes important when you need to decide, is VPN the way to go, or is Direct Connect the way to go? Because just to mention to you, data transfer out of a Direct Connect is actually cheaper than data transfer out of a VPN. Okay, in an architecture where you're doing Direct Connect transit gateway, same region, because you don't have a wide footprint. So you have your Direct Connect circuit from your data center to AWS, an AWS location, and then you have that terminated through a Direct Connect gateway to a transit gateway. For this kind of architecture, the port hour rate for the Direct Connect circuit holds, and then there is a data transfer out charge back to your customer router and your corporate data center. No cost on the Direct Connect gateway, the construct. However, on the transit gateway side of it, you've got a per GB data processing charge for every data that is processed through the transit gateway, as well as the attachment charge that is attributed to the Direct Connect gateway and the VPC. What about if I have one circuit, Direct Connect circuit, and I want to leverage that across different AWS regions because that architecture is supported using a Direct Connect gateway? What does it mean? For this kind of setup, the charge will be on the port hourly rate, right, for the Direct Connect circuit. And then depending on the region, right, because different AWS regions would have different data transfer charges, right? So that particular charge for data transfer out will be dependent on the source region. So you kind of have to think about that. What regions am I coming from? Am I transferring data from to my corporate data center? And to kind of summarize it and provide you a high-level picture of the things you need to think about, we provide you with this resource that, dependent on the architecture or multiple sets of AWS services that you want to use, then this summary here provides you with a bit of a guide, sort of guidelines on what it will mean from a data transfer cost point of view, whether there's a processing cost or that can be done over direct connect or not. And it's important, you can use this, to kind of deliberate within the networking teams on what's the optimal architecture, dependent on technical as well as business requirements that come from, the different stakeholders within the organization. And then to just, paint at a high level, some resources you can use to do a little bit more research on cost and what it means for hybrid networks. Is a couple of resources that you can look at, and you can review them at your own time. And with that, I will introduce Ashraf again to take us through the last pillar.
Thank you. Awesome. So now we're going to talk about the last pillar for the hybrid network well-architected framework. And this is the newest pillar for the well-architected framework, sustainability. Very hot topic these days, and how to reduce the carbon emission for your workload in AWS. Here we're going to talk about some of the best practices and design pattern that can help you define and understand the environmental impact of the workload that you run in AWS cloud. And we're going to talk about some design principle around this. Design principles for sustainability. The first thing that you need to think of is to understand your impact. You need to know that what you run in AWS cloud is actually compute resources that uses energy. You need to run it. There's data center power and all that. So you need to know how much carbon emission you actually use in the cloud, and also define your sustainability goals. You need to set your KPIs, that how you need to drive your carbon emission usage and predict your workload in the future to adapt to it. Maximize utilization for your design patterns. Make sure that you right-size your EC2 instances. Don't over-provision, so you minimize how much compute power you need to run in the data centers. Anticipate your workload and the changes that can happen to the business, and adopt the newest and the more efficient hardware and software that we offer from AWS that can help you meet your sustainability goals. And we're going to talk about it a little bit in using managed services and how it can help reduce the carbon emission usage that you have. To track your carbon emission usage, we launched the AWS Customer Carbon Footprint tool that help you understand how much carbon usage you run in our data centers, and you can actually understand it across services, across regions. We're building more and more features to the tool to provide you with more information about your workload and how it can contribute to your sustainability goals. And then to talk about best practices when we talk about sustainability, there's multiple areas that we can focus on. We can talk about the region that we need to use to run our workload. We need to understand our user behavior. We need to understand the software and architecture patterns that we use and how it can contribute to the overall resources that we run. Data patterns, hardware and development and deployment processes, it's all areas that we can focus on. And today we're going to talk about a few of them. The first one is region selection. And first we spoke about selecting the right location to run your workload from a performance perspective, right? But here we're going to talk about it from sustainability perspective. AWS is committed to run renewable energy in all of our data center by 2025. And from a region selection perspective, you need to choose the region that is closer to the new renewable energy projects that will help you reduce your carbon emission usage. And in the link there, you can find out more about our projects and what is the best region that you can utilize to meet your sustainability goals. When we talk about maximizing utilization, we talk about right-sizing your workload and choosing the right architectural pattern to make sure that you don't over-provision your resources, you don't use more power in the data centers, which will lower your carbon usage. Also, minimize the data movement across networks. Only back up data to AWS when it's actually impactful for your business and your workload. When we talked about Direct Connect to build your hybrid network, choose the right bandwidth for your Direct Connect link so you don't over provision and you use the resources to the maximum. Choose the right protocol for your workload, and also, when possible, implement quality of services in your data center routers. And the last one that I want to touch base with is AWS Managed Services. AWS Managed Services, it helps you because AWS take over the infrastructure and how we scale internally and how we take over of the infrastructure. You kind of share resources across different customers, which will share the carbon emission across multiple customers, and AWS will help to minimize the carbon usage there. For example, if you're using site-to-site VPN to build your hybrid network, you can use EC2 instance to run your VPN software appliance on it, but then you need to take over of provisioning that EC2 instance, choosing the right instance type. You might sometimes over provision the EC2 instance for your workload. So if you used a managed site-to-site VPN, AWS will take care of that, and then you will minimize the carbon usage and help meet your sustainability goals. So these are some of the things that I wanted to cover today for hybrid networks. There's a lot of things that we can talk about for sustainability perspective. It's a new topic. It's very hot in a lot of regions. And these are some of the resources that will help you understand better and find out more on how to drive best practices for sustainability. This kind of ramp up the discussion for the 6 pillars for the well-architected framework for hybrid networks that we covered today. And there's a lot of things that we can talk about. And if you have any questions that you have for us or you wanted to learn more, we're going to be just standing here. And you can provide us feedback for this session so we can improve in the future. And thank you for joining, and enjoy Boston. Thanks.